Hello and welcome back. In this video, I want to show you how you can prove Newton's equations of motion, also known as Newtonian equations of motion. The first equation of motion, V is equals to U plus AT. The second equation of motion is V square is equals to U square plus 2AS. And finally, the third equation of motion is S is equals to UT plus half AT square. These are the three equations of motion, also known as Newtonian equations of motion. To prove the equation on the left side, we know that acceleration A is equals to the change in velocity divided by the change in time. So acceleration is therefore equal to acceleration A is equals to the final velocity minus the initial velocity divided by the time t. So acceleration is equals to the change in velocity divided by the change in time. Acceleration is therefore equals to the final velocity v minus the initial velocity u divided by time. Now to make v the subject, we need to cross multiply the equation. We know that a times t is equals to a t is equals to 1 times v minus u is equals to v minus u. To make v the subject of the formula, we have to move u to the side of the equation, or we have to add u to both sides of the equation. We know that a t plus u is equals to v. Now at plus u is equals to v, which implies that v is equals to u plus at. So this is how you can prove the equation on the left side. To prove the equation in the middle, we know that average velocity, abbreviated as AV, is equals to the total distance. In physics, distance has the symbol s divided by the total time. The average velocity is equals to the total distance divided by the total time. The average velocity, again abbreviated as AV, is equals to the average of the two velocity, which is the final velocity plus the initial velocity divided by 2. The average of these two velocity is the final velocity plus the initial velocity divided by 2. Since the average velocity is equals to the total distance divided by the total time, and the same average velocity is equals to the sum of the two velocity divided by 2, then mathematically these two are equal. Therefore, we can say that s over t is equals to the final velocity plus the initial velocity divided by 2. Now, our goal in this equation is to make s the subject. To make s the subject, I have to multiply both sides by t. I multiply this side of the equation by t, and also multiply this side of the equation by t. Therefore, s is equals to v plus u divided by 2, all this should be multiplied by t. Now, making this equation, if you look at it, the only quantity that is missing from this equation is the time. Therefore, we have to make t the subject in this equation. To make t the subject in this equation, I have v is equals to u plus at. Now, to make t the subject, I have to subtract u on both sides. Therefore, I have v minus u is equals to 80. And finally, to make t the subject, I have to divide both sides by a. I divide this side by a and divide this side by a. Therefore, t, which is the time, is equals to the final velocity minus the initial velocity divided by a. Now, substituting t here, I know that s is equals to v plus u divided by 2. Sorry, that does not look like a 2. Divided by 2 multiplied by t, and we said t is equals to t, and t is equals to v minus u. I have v minus u all over a. So these two are multiplying each other. Now s is equals to v plus u into v minus u is equals to the difference of two squares. That is equals to v square minus u square all over 2a. Comparing this equation to this equation, we know that we have to make v the subject of the relation. Before we do that, let's cross multiply this equation. This is like over 1. Now, cross multiplying this, s times 2a is equals to 2a s is equals to v square minus u square. Now, to make v the subject or v square the subject, we have to add u square to both sides. Therefore, 2a s plus u square is equals to v square. This equation can also be written as v square is equals to u square plus 2a s as required. Again, we have proven the second equation, which is the middle equation, v square is equals to u square plus 2as. To prove the equation on the right side, earlier on in this video, we said that s is equals to v square minus u square divided by 2a. Let me write that. We said s is equals to v square minus u square divided by 2a. If you take a closer look at this equation, you will realize that the only quantity that it lacks, or the only quantity that is missing here, is v. So that means we have to substitute v here in this equation. So we said v, the first equation of motion, which is v is equals to u plus a t. This is the first equation of motion. So in this equation, the only quantity that is missing here is v. So let's substitute this u plus at in the place of v here. S is equals to, we said v is equals to u plus at, so we substitute that u plus a t. So we substitute this in the place of v, but v is squared here, this square minus u square divided by 2a. So let's open this bracket. So s is equals to expand this really quickly, first I have to say u square, then I have to multiply this 2 by everything that is in this bracket, so it will be 2 times u times at, that is plus 2 u a t, and finally I will end it by saying at square, that is a square t square, and then we have minus u square. Now what is u square minus u square? All over 2a. These two are like terms. U square minus u square is 0. Let me cancel those. I'll cancel these two because u square minus u square is 0. So we will have s is equals to 2 u a t plus a square t square all over 2a. Now this can be written as s. When you split this can be written as s is equals to 2 u a t over 2a plus, here I will have a square t square all over 2a, and finally s can be written as 2 divided by 2, they will cancel and a will cancel. On this side I will have just ut, because 2 can go into itself once and a can go into itself once, they will cancel each other, plus here if I factorize half it will be 1 over 2, so a can cancel with one of the a's because there are 2 a's here, so the a at the bottom can cancel with one of them. I will have a and t square because there is no t at the bottom. So there you have it. We are able to prove that s is equals to ut plus half ad square, just like we have on top. So this is how you can prove Newton equations of motion, also known as Newtonian equations of motion. Thanks for watching. If you like the video, give it a thumbs up, and if you haven't subscribed, please subscribe to my channel. I will see you in another video. Bye.